So last week, we discussed atomic theory. Scholars, there should be no talking. Thank you. So we started with atomic theory, and we began looking at atoms and periodic table entries. So we'll get our periodic tables soon, I'd say next week. And we looked at a periodic table entry like this one. So we started with hydrogen, but that's a little simple. So let's go with helium. And helium has atomic number 2 and a mass of roughly 4.0. Alright, so we can draw a diagram that represents the helium atom. And we say to ourselves, atomic number 2 means what? What do we learn when what information does that tell us? What do we get from atomic number equals 2? What's going on here? Number of what?
Number of protons.
Protons. Okay, so 2 protons, and we represent those protons with a little plus sign, right? So we draw, where's a good spot for this atom? I'd say right here. So we draw a little plus sign here, and then we draw a little plus sign here. So atomic number is 2, we've got 2 protons. The protons are located where in the atom? In the middle, which is called what? Starts with an N.
Nucleus.
Nucleus, good. So the protons are in the nucleus of the atom. Look, if that's news to you, write that down, right? Protons are in the nucleus. What else is in the nucleus? We've got 2 plus what gives us 4? 2 plus what number gives us 4? 2, okay. So then what's the other 2 that we've got here to give us a mass of 4? We've got 2 what? 2 neutrons, good. Because neutrons also have a mass of 1 atomic mass unit, okay? 1 AMU for neutrons. Now, to balance out the charge on the 2 protons, we're going to need what?
2 electrons.
Ah, 2 electrons, very good. Okay, so those electrons go here and here. And that's the first energy shell, okay? Can the first energy shell hold more than 2 electrons? No. So we have to add what?
Another shell.
Second energy shell. Okay, and that's really what we're getting toward today. So we've been thinking about the nucleus and protons and neutrons, and we've been thinking about how electrons are arranged outside the nucleus in the electron cloud. So remember, does this little circle indicate a circular orbit? Do the electrons go around the nucleus like the planets go around the sun? No, they don't. Okay? They do not. They exist in a spherical cloud. Alright? So again, if that was news to you, write that down. We've discussed it for the last 2 lectures. In the 3rd lecture, we're still discussing that this circle represents an energy shell, not a circular orbit. Okay? The electrons don't go in little circular orbits. Instead, they exist in a cloud. Alright, so this is helium. Let's go with something a little bit larger, and let's take a look at something we haven't drawn yet. So here's a molecule an atom that's really important for life, okay? So carbon has atomic number 6 and mass number 12. And so what I want you to do is tell me how it should be drawn, okay? Because we're videotaping the lecture, we're going to go ahead and go a little quickly so that the video makes sense. But let's take a look at this guy. So atomic number 6, mass number 12. What does that tell us? Milagros, first piece of information.
It's going to be 6 protons.
6 protons, okay. Atomic number is 6, so we have 6 protons. So we've got to draw 6 little positive symbols in the middle here, right? 1, 2, 3, 4, 5, 6. Okay, great. And then we've got this 12 down here. So who else can tell us how we go from 6 to 12? What's happening there? Therese?
We add 6 neutrons.
Good. 6 neutrons, because the neutrons also have a mass of 1 what? It's in your notes. What's the unit for mass of like
AMU.
protons? Good. AMU. Which stands for?
Atomic mass unit.
Atomic mass unit. Very good. Okay. So we've got 1, 2, 3, 4, 5, 6 neutrons in the middle too. All right. And then how many electrons are we going to have in this in this atom?
6.
6, because we have 6 what?
Protons.
Protons. Okay? So 6 protons, you got to have 6 electrons. Now we said earlier that I can put 2 in the inner shell. So then how many go in the outer shell? 4. okay? So 2 plus 6, that gives us 4. So this is simple math. This isn't complicated math. And again, this is chemistry class. It's not a math class, right? But we have to be able to do a little simple accounting like this. Okay, this isn't above anyone's level. So here we go. All right. Now let's go ahead and take a look at this situation, okay? So what's crazy is that helium has 2 electrons in this first shell, right? But here's what you might not know. Helium's also got a second shell. And beyond that, let's get wild, it's got a third shell. And you know what else it's got? A fourth shell. It's got a whole bunch of shells, right? But these electrons populate only the first shell when they're in what's called the ground state, okay? So electrons without excitation, without any energy to get them all pumped up, they just stay in the ground state, right? So here's what you need to know. When When electrons or atoms absorb light energy, electrons can become excited. Okay? Excited electrons rapidly lose their excitation energy and release light. Okay? So the electrons get excited, and this excitation could move, say, one of these electrons. Okay? So this guy could get excited, and this guy could absorb light and move to the third shell. Okay? And he'd be excited. And then if an electron, if he were to then fall back down, say from, so this guy absorbs light and goes here, right? And let's just have some fun, okay? I'm going to erase carbon. So now I'm going to draw helium again. So this guy over here, okay, with 2 electrons here and here, this is called ground state helium. Okay? Ground state helium. The electrons are not excited. But if this guy absorbs light, and this electron goes over here, now we have excited state helium. Okay? And this guy can lose energy. So and release light. Okay? So this process here, when this electron falls down in energy level, releases light. And what's really interesting is, This is called electronic relaxation. So it's relaxing back down to a lower energy state. But here's what's crazy. Here's what's absolutely nuts crazy. When an electron goes from the first state, from the first shell to say the third shell, that requires absorption of UV light. That's ultraviolet light. That's light we cannot see. Okay? Or some other form of energy that provides an equivalent amount, okay, of energy so this electron can go from here to here. All right? When this happens, okay, when it goes from some shell down to the second shell, so wherever you're going from down to the second shell, it actually releases visible light that you can see with your eyes. Sounds nuts, right? But it's true, you can actually see this stuff, okay? And what that light looks like, and what energy it has, what frequency it has, what that experiment's all about, we will see in our lab next time.